Today we're going to talk about exponential functions and mostly just comparing linear with exponential functions. So I have images here of a linear function, obviously makes a straight line. We've been studying those. You studied those in 8th grade math. And then here's exponential functions. It shoots up like a rocket ship is what I use to describe it, a rocket ship. And let's look also at their function. So the parent function of a linear equation is y equals x. Notice there's no exponent, there's no radical, there's nothing strange about a linear function, y equals x. We're used to seeing y equals mx plus b. So there can be a coefficient, but there's never an exponent on our linear functions. Now, our exponential functions are y equals a raised to the x. Now, a could be any number, but notice our x is our exponent. The x is the exponent in an exponential function. And again, exponentials have this kind of quick increasing shape like a rocket ship, where linear functions are very constant and straight, like a line. So on these next examples, determine whether the rule or the equation, the function, represents linear or exponential. So number one, y equals 4 times 5 raised to the x. That x is my exponent. Therefore, this is an exponential function. Number two, f of x equals 7x plus 3. So this time they've replaced the y with f of x. No big deal. We do have 7x plus 3. That reminds me of slope-intercept form. We just have x without an exponent. This is a linear function. Number three, f of x equals -5 times 25 hundredths raised to the x. Again, the x is our exponent, so this is an exponential function. Number four, y equals 1/3 raised to the x. Again, the x is our exponent. This is an exponential function. Number five, y equals 4 times x. 4 times x. X does not have an exponent. There's nothing strange here. This is a linear function. We could graph that and it would be a line. Number six, f of x equals 2 times 2 raised to the x. You have an exponent there with an x, so this is exponential. Now let's look at tables and determine whether our table is linear or exponential. If I have the table in number 7 has 1, -7, 2, -11, and so on and so forth, let's consider our rate of change, how our y values are changing over our x values. Change in y over change in x. As I move down, what's happening to y? How did we go from -7 to -11? We subtracted 4. Now, if you ever have trouble figuring out your rate of change, you can always work backwards. Start with -11, the second number, and subtract it from the first number, -7. That's going to give us -4. Does that pattern continue? Yes, from -11 to -15, subtracting 4. It's continuing subtracting 4 to make -19 and subtracting 4 again to give us -23. So our change in y is -4 over, how's our x changing? Adding 1 each time? Sure looks like it. Adding 1 each time here on our x values. So this has a rate of change of -4. Now this is constant, and it is by adding or subtracting each time the same value. So this is a linear function. Linear functions change by a constant rate that adds or subtracts each time. Now let's look at the second one. Number 8 has a table. And as we look at our change in y over change in x, how did 4 turn into 8? Well, maybe you think it added 4. Does that pattern continue? Well, 8 plus 4 should have given me 12. 16 plus 4 should have given me 20. Something different is happening here. Instead, our rate is multiplying. Do you see that? 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, and 32 times 2 is 64, while our x values are still adding 1 each time. So since this table is multiplying each time, we are going to have an exponential function here. This table represents an exponential function. The statement at the bottom, exponentials change by a constant percent. You might see some of those phrases in our questions on test and benchmark, so that will be helpful. Exponential functions change by a constant percent that is multiplying each time or multiplies each time. And so that's exponential functions, guys. So we are starting to build onto our function families that we have learned and studied. We started talking about functions and what functions were in general. We spent some time looking at linear functions. Now we're going to spend some time looking at exponentials, and we'll move forward adding to these different types of functions that are out there called function families. We are going to look at the pictures of the graph to determine whether it's linear or exponential, look at the rule or the function or the equation and determine whether it's linear or exponential. And lastly, looking at a table to determine if a function is linear or exponential. Practice those on Delta Math, guys, and I'll see you in class.